All right, guys, let's crack the code to graphing the trigonometric function of cotangent. The equation is y equals cotangent pi x. Now notice the coefficient is a pi, so that's in radian measure there, which means along the x-axis we're going to have conventional numbers. But here's what we're going to go through. We're going to go through 3 simple steps. The first step is we're going to work out what? We're going to get the period. Now the period is what? The distance that the curve moves along the x-axis before it begins to repeat itself. So we're going to work out the period. Step number 2, we're going to split it in half, and that's going to give us the points where the cotangent curve cuts through the x-axis. They are the x-intercepts. Now please note that cotangent is the reciprocal, the flip side of tangent. So wherever tangent had x-intercepts cutting through the x-axis, now with cotangent becomes asymptotes, and vice versa. So wherever we used to have in tangent mode asymptotes, now becomes x-intercepts. So be aware of that. That's going to help us in terms of drawing it. We're not going to use a calculator. We're not going to plot the points with any type of technology. We're just going to sketch them through familiarization and understanding. So here's what we're going to do. Let's work out that period now for step number 1. The period is pi over b, and b is the coefficient, as I said, is pi right over there. So we're going to work that out. So let's start to work that out. So if period equals pi on b, it simply becomes pi on pi, which means it equals 1. Okay, if it equals 1, let's mark out positive 1 and negative 1 either side of the y-axis. So here's our y-axis. Let's go across to 1 all the way here, positive 1. And then all across this way to negative 1. Okay, conventional numbers. We don't have radian measure numbers there. Okay, what do we do now? We split it in half. So half of 1 is simply a half, and the negative 1/2 on this side. Okay, we've split it. Now, do you remember with tangent, where did the curve cut through? With tangent, it cut through the origin right here. Now, if tangent of 0 equals 0, it's fine to cut through there. But when you reverse it, reciprocate it, and you go through 0, it becomes 1 over 0, which means for cotangent, this place here, right there at the origin, becomes undefined. And if it's undefined, we put a dotted line. It's called an asymptote. So right along the y-axis, first place we go to is we put an asymptote right through there. There it is. The curve never touches, never crosses, gets closer and closer, but never touches. There's our first asymptote. The next asymptote, since the period is 1, will repeat itself from this exact point to here at number 1. So let's put another asymptote there. It helps knowing that period. There we go. There's the next asymptote, period of 1. Let me just mark it out in red. So that distance across here is the period, and that equals 1 right there. And it goes across the other side too. So that period's going to go over to negative 1 across there, so we can safely put an asymptote there. So let's do that all the way through negative 1. So that's going to go right through there. So we've got another asymptote. Asymptote negative 1, asymptote through the origin 0, and asymptote through 1. Now if we split it in the middle in half, that's where it's going to be an x-intercept for the cotangent. So in the middle along here at 1/2, we have a curve. Now all you need to know with cotangent, it's going to have the opposite slope when you look at it to a conventional tangent. Now which way does a tangent go? It goes this way. With a cotangent, it's going to go the opposite way. So why don't we go ahead and put one in. So let's put it through there. The x-intercept is at 1/2. So let's put it in. It's going to look like that and across like that. There's our cotangent curve right there. It's going to repeat itself across over here. So let's put another curve parallel to it, kind of parallel, but similar to it as it repeats itself. There's the curve again, and it looks like that, cutting through the x-intercept of 1/2. There it is right there. So that's cotangent. Let's have another look at the period because it does repeat itself. And we can't go on too far because with this period, we have a limitation of this domain between negative 1, which is this asymptote here, negative 1, all the way to positive 1, this asymptote right there. So we don't continue past that particular domain. So let's have a look here with the period. I'm going to mark it again so we get a deeper understanding of it. So the period here also is between this point here on the x-intercept all the way across to this point here, the next intercept. So that's also the period. It's wherever the curve repeats itself every time. So it starts here, repeats itself there at exactly the same place. Or if you wish, it starts at the asymptote and then repeats again at this particular part. So that also is a period. But please note, no matter where you start or finish, it's always going to be 1. And that's the period for this particular cotangent curve. Hope that helps.